Great. Okay, so I'll try to share my screen first things first. There you go. Okay, can you just confirm you're seeing my screen and everything? You can hear me as well? Is it all good?
Yes.
Okay, perfect. Great. So, hello everyone. My name is Sergio. As you already know because of the nice intro by Maho, I am the co-founder and co-CEO of Beekee, based in Geneva, Switzerland. We are a spin-off of the University of Geneva, of the Learning and Teaching Technologies Lab, created 4.5 years ago, along with my co-founder Vincent, who's also somewhere in the call. You can say hi to him. He's also joining us today. With me also, there's other team members, Nicolas, Hervé, as you can see, he's raising his hand somewhere, and also Malik, who will be introducing, presenting part of this doing this part of this presentation today along with me. So yeah, I'll try to keep this. We'll try to keep this session as informal. Remember, this is a coffee sip, so if you don't have a coffee, well, get yours. I have my Swiss course mug here, and I'm in Colombia, by the way. So everything that is all about educational and coffee and technologies, I'm always in. So yeah, just to say hi, I really thank you for this opportunity, all the AI for Education team. Well, today we're here because we put a fancy name to what we're doing called the Apex project. I'll tell you more on what it means, but as you can see, what we're trying, or you already know from probably the beginning of this call, is that we are trying to work in low resource or resource limited environments that, and of course, when we think about those places, you will see that there's probably more than we think, more people doing this, basically in this kind of environments than you can imagine. And the idea is to really imagine how to enable some AI applications for supporting certain educational processes using low cost, cheap budget hardware and open source software mostly, or entirely. And today we're going to share with you what I have found so far and some ideas and challenges that we have found, because that's also about sharing what doesn't really work to make sure that nobody wastes time on things that don't work, shouldn't be waste time on. And anyway, but there's a lot of really good things. And if you saw a bit of the post, there's good news. So let's get started. So yeah, what kind of problems do we face at Beekee? Well, do we help alleviate of our partners and customers? Well, many concern the access to digital learning. When we think about this, of course, there is the problem of access to the internet. This is a major point around the world. There is a whole framework that defines what is meaningful access to the internet. Having zero cost Facebook or Instagram or TikTok is not meaningful access to the internet. So many people are considered to be connected, but they cannot really use applications or software or platforms that would help them to learn, to have some sort of services. So of course, access to the internet and the stability and the cost is a major blocker, but it is also blocker. There are also other blockers such as electricity, right? When we think about how unreliable electricity is in many countries that our partners operate and clients operate on, it's a major point. So at Beekee, we try to, of course, take that dimension into account, which is also particularly relevant for AI. We know that the use of electricity from AI is also huge, and we should probably be a bit more aware of that. But there is other concerns that are growing: the security, maintenance costs of different locations. So our partners are faced with a lot of different blockers that make the use of or access to digital learning very, very, very hard. But there's also, on the other hand, the quality of education. There is this debate of media over methods. So how sometimes we privilege transmissive approach and don't really make peers learn with each other. We don't create those sessions in which they actually do things together. And what we're trying to really tackle at Beekee is basically these two major dimensions, like how to enable access to digital learning, traditional e-learning, but now also AI for supporting educational processes. And at the same time, how do we improve the quality of what we're doing with that technology when it makes sense to use technology? We're not for using technology at all times. There is a certain point and time when this makes sense to use technology, and it has to be carefully thought and designed. So at Beekee, we help tackle these problems. Particularly the first problem of the internet access. If you see this graph here, it looks like really good news. because you would see that, wow, we are almost at 70% of the individuals around the world connected to the internet. So that sounds like good news, but in reality, that means that there's a third of the humanity that's still offline today. And that's a lot of people. 2.7 billion people, it's a lot of people. And we know that they are what we call the digital gap. They're there. And imagine that's a major problem. But also, when we drill down in terms of the geographical distribution or where these people with access to the internet, we can see that in Africa particularly, there is a very low internet penetration. And if we drill down by income, there is 27% only of people in low income countries that have some sort of access to the internet. So again, if we're thinking about AI, we should also think about how we're going to deploy it and how it's going to be serving the underserved or getting to the last mile. And that's what we're trying to do here at Beekee with this exploration offline AI, just pretty pro. So just to give you a quick word of what we do, we manufacture some devices, but our business is not just to manufacture devices, it's to really create solutions. These devices are very small, as you can see here. I'm showing you, we call the Beekee box. This little device, again, as you guessed, it's a Raspberry Pi enabled device. There's a lot of things going on inside, but long story short, it's a very portable and multifunction device. You'll see what's inside. But there's another device that we manufacture called Beekee Hub, and that one is pretty much the same as the box, but has the ability of going online at certain points, so can make use of the mobile network. What we want in a nutshell is to enable or to blur the lines between online learning and offline learning to make sure that they both have meaningful learning experience. And the fact that these devices are, of course, low energy consumption, they should also guarantee classroom time pretty much all points. So again, thinking about electricity concerns, that is why these devices are so small and they are very low energy consumption. So that enables us to go really to places that are very, very, very complicated in terms of infrastructure. So what's inside of these devices? Well, our approach is to create multiple, platform that holds multiple apps or tools that they all are meant to support collaboration and learning. Again, we're called Beekee because we believe not necessarily only in bees, but also in collaboration. Like, what can we do while we are together? How can we enable people to work, to learn, to discuss, to argument while they're in the last mile without proper access to the internet or with power cuts, for instance? So our devices contain multiple apps and platforms, as I just said. They're all for teachers and learners in your processes. We have learning management systems that are running there. Also other tools that probably, if you have ever used Kahoot, Mentimeter, Padlet, kind of tools for making learning a bit more engaging or active. We also have that, and it's part of the offer. So it's a platform that runs a lot of different things, right? And of course, what we want to do here is to enable clients and customers such as Doctor Without Borders to do their jobs in last mile places, to train frontline health workers to get really reliably. And for instance, South Sudan, where we have these photos. This is Central African Republic. And again, we're doing many things. And you can see the lady, she's holding a Beekee Hub that is pretty much holding a lot of courses and apps that will enable collaboration. But we know the reality in the world, it's very complicated. We know there is a lot of different places that look like this. We can think of places in Central, South America, Southeast Asia, Africa that have this kind of visuals. And as you can see here in the picture, they do have some sort of connectivity, but it's insufficient for e-learning. So we're trying to build, and this is again for higher education as well, we're trying to create those spaces in which learners can always reliably connect to a learning management system, collaborate, engage, and then whenever there's internet, that's what we call offline first. Whenever there's internet, we can actually synchronize and send the data to a server. In this case, we do this with many people, including the Arizona State University, and we're kind of pioneering this offline first approach, which is, as you probably guessed, what we're trying to do with the AI as well for education. So this is just to give you a bit of background of what Beekee does. But we not only work with large organizations, we also work with smaller organizations or individuals. In this case, in refugee camps, as you can see Victor, our friend now, he's holding a Beekee box and he's using it for training, facilitating mediation, building skills in the refugee camp. So long story short, we do a lot of things in 4.5 years doing these projects. But today we're here because we're talking about Apex. What is the objective is really to assess both the viability and pedagogical relevance of current lightweight AI, and all of this running again on single board computers for the record we're using Raspberry Pi, and I'll tell you why later. But why do we think this is important? Because we are all, I guess, we're here in this call, we are all convinced that AI could bring a lot to education. It could help improve learning outcomes if it's used correctly. Of course, there's this huge development in terms of AI for education, but it's not really for all as it's being done right now, because we know there's a lot of blockers in terms of connectivity, for instance. If you know the Giga project from the ITU, it's all about connecting schools, and they are really trying to push this, but there will be many decades until we get this solved. And again, we're thinking about just connecting them to the internet. So what we're trying to do here is to explore more lightweight approaches and see if we can identify some AI tasks that could run on these devices that can support and alleviate some of the problems that teachers and learners could face. So I think this, if we don't do anything, if we really think about AI like as much as we do, but we don't think about the implementation of AI in the last mile, which is what we always kind of keep in mind at Beekee, we just risk of widening the gap even more. So this is the whole point, really, to bring to our attention that we should kind of think about who's going to, particularly low middle income countries, who's going to be using this. So before we get into the actual tech part or more the technical aspect, as I said, I'm joined today by our team. There's Vincent to my left or right in the photo, I don't know. There is also Malik in the middle. Rafael, I think he's connected somewhere, so hello, Rafa. And there is also Nicola, who's next to me. So we all have been collaborating and contributing to this project. So feel free to, if you have questions, they'll be also answering via the chat. I'm very mindful of the time, so sorry if I am running a lot. I just want to get everything evacuated. So yeah, please bear with me. Just to tell you that everything we have done, we have compiled in a knowledge base that we will share, and we will, of course, deliver to AI for education. So all the tests, all the approaches, all the challenges that we have faced, they're all documented in this platform that we will do some sort of transfer. Maho, you will guide us on this process, I guess. But yeah, it's all there because that's the spirit, is to share and to understand what is possible and what's not. Right, so let's get a bit more into the technical aspect. So just to tell you more about the hardware setup that we use in the project. So we're talking about Raspberry Pi 5. That's the latest iteration of Raspberry Pi, the version that has 8 gigabytes of RAM. We chose this hardware, the single board computer, because first of all, that's the one we use at Beekee, so we know it very well. But it's also affordable and perfectly capable of running some lightweight AI models. Also because Raspberry Pi guarantees to continue the manufacturing of most Pi models for several years. And that's also an important point in terms of sustainability. And we know that there's probably cheaper and more capable single board computers, but we chose Raspberry Pi for that reason. And again, we're talking about this device costs less than 100 Swiss francs, so it should be less than $100 as well. So it's affordable in that sense. We're using Raspberry Pi OS without desktop environment, a headless server, because again, we want to then allocate all of the resources to the actual AI work. Then in terms of storage, classic SD card. In this case, we even use one that is very limited, just to try experience of using very cheap and low cost, low cost hardware. Again, less than $50 francs. And there's some other accessories that are official ones, so we didn't customize the hardware in any way. We just used the official charger, and there's a case, the fan. So again, we're just trying to keep it as standard as possible. And all of these accessories are less than dollars or francs. But then if you want to use these devices in kind of an off-grid situation, you will need some extra hardware. In this case, a folding solar panel, which is one that we can bring in our backpacks and then actually unfold somewhere that is direct sunlight, and some sort of battery. Again, this is where prices range between $100 and $200 dollars or francs. So this is just to give you an idea that this is very easy to find a hardware that you can procure in most countries. So let's talk about what we did in reality. So of course, we try to capitalize on what was done. And as Maho introduced, there is the AI ideas for AI education portal that you can continue contribute. And then there are some ideas that we explore. We identify 17 of those, and including text summarization, translation between languages, audio transcription. So there's a lot of things that we consider. But today we'll focus on 3 for different reasons. One, the interactive chatbot, which is of course one of the most widely used applications for AI that basically everyone has been using so far. Formative feedback assistant. Again, I'd say formative feedback because we think, or we kind of advise AI not to give directly grades to people, to students. It should be a process of feedback before just putting labels and numbers to learners. That's something very important. So that application. And the last one is transcription and summary, which we thought, again, we have all been into these calls in which there's an AI assistant on Zoom or whatever, so you can get that also happening in the offline space. So we did this selection, and then this is what we're going to demo today or show you a bit more what we did. Right. So I don't know, Malik, if you would like to take over. You are or as you wish. So just to introduce the first part, which is interactive. And actually, I think you don't need to mute.
Okay.
Because you're using, so you can go.
Perfect. Hello, everyone. So I'm Malik from Beekee team. So for the interactive chatbot, we use the Llama 2 model, 7 billion parameter. It's a quantized version. So we choose the quantized to 4-bit because it was the bigger model that we was able to run on the Raspberry. If we take the one at 6-bit, it's not working. We used a GUF format, who is a format of make able to use model on CPU, and with the Llama CPP framework, who is an open source framework, make possible to use AI on CPU again. And we took our model from Hugging Face platform, where there is one user who make a lot of quantized model for us.
Excellent. So I'm gonna go next, right?
Yes.
Probably a bit on the software stack again.
Yeah. So again, we use the Llama CPP framework. It is a really nice framework who give us a lot of control on running AI model with a lot of hyperparameter and everything. For the demo, we use Flask API and Streamlit to Python web framework. And again, we use only quantized model because we need a lightweight version of AI model.
Right. Okay, so some of the things we measured are here shown. So inference time. There was someone who I think previously before the call submitted some questions, so we measure that, of course, and we'll share with you how much time it takes to load. Power consumption is very important as well, since we're very much into understanding the power consumption of these different models, and you will see that that's also reported. Temperature of this memory usage, and the usage of also CPU as well. Yeah, so I think again, all of this we are measuring against the interactive chatbot application because it's one that is pretty much a good benchmark. It gives a good idea of full consumption of resources. It's very resource demanding. So that's why we are measuring all of this against interactive chatbot, which is a standard application. So I don't think we should. It's time to demo it, or should we?
Like you prefer.
I think we probably go first with the results.
Yeah.
And then we do the demo.
Yeah. Okay.
So okay. So I will just go next. Yeah.
So we measured the different metrics we showed before. The first one and the most, I think, interesting one is the inference time. So the time the model make to generate response. So we try different scenario with 1, 2, 4, and 8 users simultaneously, and 1, 2, 3, or 4 thread. So usage of core of the CPU. So the Raspberry Pi 5 has 4 cores. So for each thread, we have 1 core. So it's like to know how we can manage the usage of the CPU resource. So what is interesting here, it's for one user, we see that from 1 thread to 2 threads, we divide the inference time by 2. But after that, we stay at the same rate, so there is no improvement by using more core after 2. So it's interesting. We cannot like optimize more from one user. For the other scenario, we see that there is improvement, but we see too that the inference time begin. So the y-axis is the millisecond per token. So for one user, we see that with 1 thread we are at like 0.7 second per token. So it's a bit slow, but it's okay. And we see that after that we are at like 300 for 400 millisecond per token. You will see in the demo, it's quite acceptable. But after, if we make more users simultaneously, it become not efficient. The time of response become really variable and really high. And at some point, it's not possible to use it in a live.
Yeah, I think this is one of the takeaway messages.
Yes.
First one is that, of course, it's not a huge web server capable of holding a lot of people working on it. So for the chatbot application, at least, one of the things we learned is that we should keep the number of users less than 2, actually, because then you can see that as of 2, the time actually pretty much doubled for 1 core. But then, you know, we kind of restrained already the range of possibilities to the application, because we know that more than 2 users pretty much becomes unusable or very annoying or very slow. I will introduce one concept later about asynchronous jobs, but we'll just continue with probably the measure. But this is one good first takeaway measure. Should we move to the next one? Yeah.
So we measure the power consumption. So it's the power consumption only of the Raspberry Pi. We didn't take account of the fan. The fan is like 2 watts at full capacity. Thank you. So again, it's for each thread, each number of threads, we measure the power consumption, and we see that at 2, 3, or 4 threads, we are at around 6 watts of working. So it's not too much. It's like the maximum that the Raspberry can do. So it's pretty acceptable depending of the use case. And yeah.
Exactly. So again, it's important to know that here we're in almost any case under 10 watts, even with the usage of fans. So again, we're talking about very low energy consumption, which is, and again, this is again for what we've seen, it's a good implication. So another takeaway message is possible. Power consumption is decent. It's low. I mean, it's nothing. Doesn't require special gear. But yeah, we'll get to that point a bit later on. Moving on, probably on the temperature aspect, it's also an interesting one.
Yeah. So we use the official fan. So maybe we can imagine put it more powerful fan to keep the temperature low. And we see in this graph that the temperature is quite quickly rising at 70, 75 degrees. And we can control this temperature by using less core, but we reduce the inference time. So it's so the temperature was around 20 degrees in the room where we did the test. So we need to take account if the temperature is not the same, how much it's gonna go up.
Yeah.
Yeah.
And this is where things get a bit complicated.
So we parameterize the model to stay in memory. So it's a mlock parameter. We keep the model in RAM to be sure to have the maximum inference time and to see what the Raspberry can hold or not. And we see that for the Yamato 7 billion 4-bit quantize, the RAM is full. It's totally full with a bit of swap used. So so it's the full capacity of the model. If we don't use the mlock, we have some margin of RAM, but the inference time is low and everything. So it's the game of optimization.
Exactly, optimization, correct. And finally,
the CPU usage. So in black is the I/O weight of the CPU. So it's, you see for each graph, it's the time the model takes to be loaded in RAM. Then when the model is loaded, we have full usage of the RAM by the process user. And we see here that it's not depending of the number of users, it's full utilization. So it's a good news and a bad news. So it's good news because it's nice, the CPU it's nicely used, but it's bad news because we reach the limits of usage.
Thank you. All right, so we promised a demo, so let's pray to the gods of the demo to help us with this. Right, so here we are today with, this is just to explain you very quickly, this is the chatbot application we just showed you. It's running at the moment on a Raspberry Pi, so we're currently pointing to that URL if you want that IP here. So I'm gonna start with some questions. So hello, who are you? And we'll send it, and let's keep an eye on the inference time. Of course, there you go. Okay. Hello. Voilà.
So the model was already loaded in memory.
Exactly.
You don't see the time of loading the model in memory. It's like 30 seconds.
Yeah. Well, it's it's doing its AI things. Of course, it's gonna be. It will. It's finished. Good. I'm gonna just pop a question that it's a bit more, of course. Why is the sky blue? Probably it's a common one. So we're gonna drop that one. We wanna wait a bit on, of course, the time for that to process, and it's going somewhere, I hope. So as you can see, it's running, but it's it's just now producing answer. So there is, of course, the concept of asynchronicity that starts to be interesting, because again, if your chatbot is a very resource intensive applications, but then there is a lot of sometimes waiting time involved. So yeah, that's one of the points. Voila, it's answering interesting questions. Sky appears to be blue, phenomenon for random scattering. I think this is not true false. I'm not an expert in this, so if someone can judge the answer, it's not going to be me. Okay, first thing, we need to train people to, of course, be very, very critical, have this critical thinking.
So because it's a quantized model, the quality of response and accuracy may be less than the original model.
Mm-hmm. Yeah. I'm gonna drop one last question just to understand what was my last question, and hopefully that will go somewhere. So what you don't see is that here Nalik in real time is surveilling the device to see if it's being used, and it is running. It just takes time. Of course, this is all optimizable, and new models will be, of course, improving on this. But
and so now we are waiting the time of executing the prompt we send in. So it's like 180 milliseconds per token we send. So the more we send, the more it will take time to answer. And then when he start to answer, we have the time of inference we saw before.
Exactly. Yeah, so this is not two faults. Why is it sky blue? This is my question. Perfect, it's coherent. So that's first out of 3 demos done. Let's go. Yeah, we can keep on going on the next applications, I think. So just to tell you more about the second use case here, it's about formative feedback system. Here we're using fine-tuned model from Llama 2, again 7 billion. Why Llama 2 7 billion? So it's a good starting point for fine-tuning different models. So this is Prometheus 7 billion. Again, quantized at 4 bits, which makes size of 4 gigabytes Yeah.
So it's interesting because this model is fine-tuned from the same model we use for the interactive chatbot, sorry, and for the measurement. So it's the same as running the last task, but it is fine-tuned to be able to give feedback to a user with one question, one reference answer, and one score metric with characteristic for each score.
Exactly.
Yes.
Great.
And normally it's live.
It should be live. Okay. Let's go again.
Okay.
Let's go for it. I'm gonna copy there.
Maybe just wait that it finishes the process.
All right.
Yeah.
So I will do elevator music for a second here while it should be good now. All right. So it's not too long. There you go.
Yes.
Okay, good. Again, this is all happening on the Raspberry Pi that we have here. So it's still, it was relatively fast to load.
Yes.
As you can see.
30 seconds to load the memory in RAM.
Exactly.
Yeah.
So again, just to prove you that we're doing this in real time. So it's actually decent waiting times at that point, switching from model to model. In this case, again, this is the formative feedback application. This is I'm gonna just read very quickly the instructions. I have explained the process of photosynthesis in detail. I should cover the key steps involved. Blah, blah. So of course you get the point. This could be one part of part of the biology class or something, and then we can. I prepare an answer, of course, to
a not so good answer.
A not so good answer. Okay. Why is it not so good? Because there is some.
Yeah, I prepare an answer we are not complete to show what the model
Okay.
receive.
Excellent. Right. So
Generate feedback.
I will generate feedback, and it is running there.
So it will take time because the prompt it's really big. It's not really big, but it's a bit large because we have the task, we have the question, reference, answer, the answer of the student, and the metric and the format of the answer the model need to give back. So the time is 3 to 5 minutes to get feedback.
Again, we're getting towards the synchronous tasks that we could think of this kind of resource device can do, but it would take time. So while that is going on, I could just very quickly swap to the next use case here, which is, as I said, the transcription summary at some point, which is using Whisper.
Yeah.
So
there is a lot of people know the model Whisper from OpenAI, and there is the same guy that do the Llama CPP framework did the Whisper CPP framework, who give us the possibility to run a quantized version of Whisper on CPU. We use the Whisper CPP. We use the Whisper large model, so the V3 model, the biggest one, quantized to 8 bits. So it's a not so big model. It's 1.6 gigabytes, and it's running pretty nicely. It takes time again. It's very not just the speed, the nice part. Then we use the open source BART large CNN model to get a summary of the transcription of the audio, and it's about the same size of model. Exactly. And it takes time to get the summary, less than the transcription, but
still, yeah, exactly. So I think we just put here two, for the sake of time, we put here the actual answers that we got just priorly. We uploaded the a speech by Nelson Mandela, just to again have some reference here, and we tried to
So the audio, it's interesting is the audio, the discourse he say when he get out of prison. So there is a lot of noise in the audio. There is a really I don't know much people screaming and everything to see what the model success or not. So normally on the left you see a version with a smaller Whisper model and one version of a summarized one, and the results, I don't know if you can read, but the results are not so good. So the transcription part is okay, but a bit weird, and the summary it's really strange. And on the right part, we have a really good transcription with the large one, the Vitra large one. And we use another, the Facebook large burst CNN to summarize, to only take some sentence, more important sentence. So, and it takes a lot more time.
Mhm.
So the results are good, but again, not in
Yeah.
fluid direct way.
Correct. Yeah, but this again. Should I go see if it's finished, the other one, or do you think we'll not?
I think it's finished. Yeah.
Oh, there you go.
Yes.
So coming back to our again formative feedback application, instructions were there. This was my result, if I remember correctly. Yeah, of course. And this is the explanation. Sorry, the feedback that he provided. He said it doesn't meet the requirements. It does touch upon certain process, but it fails to detail some steps. There you go. Yeah, again, the biologist.
Not happy.
Vincent is the biologist, so he could use this as an input to understand, fully or not. But he gave us a score of 1 again. We this is one of the things we want to be very clear. This is why we need some training here for teachers as well. They just assign the score directly without them actually having this critical thinking of the different rubrics of each subject. They just take it, it's very risky. So again, this is one of the risks that we want to flag very early. There's the need of really someone that's an expert or just go through this and use this as input, but not take these numbers directly.
And if you run again the model with the same answer, maybe the response vary a bit of one, maybe it gives 2 for annotation. So there is a lot of work doing to use this kind of model.
Exactly.
Yeah.
Right. So for the sake of time, we're going to just go directly to, because it's 10 minutes before we leave. Again, we think there is a lot of, as you saw in the live demo, we managed to demonstrate some applications. They could provide sufficient quality for some educational scenarios, but their hallucinations are real, frequent, and a risk for education. That's why we need to, of course, try to, from a technical standpoint, to alleviate them with some RAGs whenever that's possible to create more cohesive and informative answers. Of course, that's the technocentric aspect, but of course, our second takeaway message is that yes, this should be only as input to, for instance, as the teacher could use for asking learners to debate and discuss the quality of a given output, given a certain criteria in a field. So offline AI is limited, but this could be actually a great opportunity to develop those critical thinking skills. And attention, there's the grades and should really be taking this area is very proceed with caution when you're thinking about using AI to automatically grade learners. This is really a zone that should be taken so much caution. We really insist. Takeaway message 3: the Llama CVP is really a simple inference framework that works well and simplifies the deployment of these models. Gives a lot of flexibility, and again for Raspberry Pi, it's an option. It's very, as you can see, this helps us to go fast. In Raspberry Pi 5, it does provide adequate computing resources for some models that are educationally relevant. Limited again by number of users. We saw that periodically we got to 2 and we reached the maximum. So 1 to 2 maximum, which limits it pretty much to the application field teacher. It can run with solar, which is very interesting. But of course, you need a bit of a setup there, have some batteries, a power bank, and you need something to actually. You cannot just plug the solar panel directly to the Raspberry Pi. That doesn't really work. You need to still go through some sort of system to accumulate electricity. And yeah, there's some applications that could help to alleviate bottlenecks in terms of education for teachers, particularly in low-middle countries. But again, we can do that rapidly as these tools are pretty much out there. We just need to really make sure that we address certain cognitive and important behaviors before just pushing AI everywhere, as we all know. I will not take too much time into the technical challenges. We tried different things such as computer visions with GPUs. We didn't have the time to study the different pedagogical interests of those, but it's possible. As you can see here in the photo, it's something that is very, very easy to plug into a Raspberry Pi. the temperature again rises, which needs probably additional cooling solutions on top of what we use, which is the base Raspberry Pi. Again, we want to introduce the concept of probably not introduce, but really strongly think about asynchronous models. So again, as you saw before, we let the thing run for a while, and then it does provide answers, but it will take some time. So that is possible. We think of queues of this for the offline spaces, queues of prompts or processing that could happen. So next steps and conclusions, yeah, this is possible. Asynchronous are definitely a future direction of interest. We do think that, of course, there are some applications that are okay, yes, use AI models on a smartphone and that kind of thing. Of course, that will happen more and more, but we do think that AI should be used in conjunction with a broader approach, for instance, with a learning management system, so it actually serves as a companion. And that's where the smartphone kind of use case limit gets to a limit quite quickly. It's not an access point for instance, for a classroom. So we do think that the single board computers, they have a room here and they could really alleviate bottlenecks. Yeah, so we do think that teaching prompt engineering to teachers and students and some critical thinking skills is crucial to really advance rapidly on this space. It's possible. We just need to do a lot of groundwork here, and probably this is one of the next directions that we'll take as Beekee, because we do a lot of education. We know, and we've been in contact with people in the field, so we would love to contribute to this. And the one conclusion that was given by the FabIn team was a spoiler alert. Can we make LLMs work offline? Yes. Doesn't mean that you can use the neural pools. Yes. No internet. Yes. What about no electricity? Yes, that too. Thank you for answering all of what we're going to say today. For spoiling the party, but fine. It's okay. You saw here in live that all these things are true. So yeah, thank you so much for your attention. And I think with that, just 2 points here. We'll be Learning Africa as Beekee in Rwanda at the end of May. And we'll be here in Geneva, AI for Good Global Summit. And of course, you're more than welcome to join. We'll have a stand with AI for Education in Beekee. So, and you will meet these gentlemen in real life. They do exist. Right, so that's it. Thank you for your attention. I hope that it was informative and useful. Thanks.
Thank you.
Thank you so much, Sergio, and apologies for the spoiler on the conclusion. I wanted to open the room for questions. I know some of the questions have been answered. Really quickly, one of our we'll start with one question from one of our team members and then open the floor. So please be sending the questions here. If we don't get a chance to answer them all, we will ensure that you get some of those answers. So Robin, I heard you have a question.
Yeah, hello, I'm Robin. I work with AI for Education. So I mean, I think it's really exciting, and it's really clear the benefits of having, you're providing a service in the hub that people connect to and use this offline. But it seems to me that this Raspberry Pi is like quite an extreme end to start with of the spectrum of hardware you could possibly look at to achieve this goal of providing, local offline LLM access. And so I could imagine the key parameters are cost of the hardware, power consumption, for inference, and then like tokens a second in terms of performance. And like this is just one end, so you're showing it really works. I understand this is what you had, because that's the board you already set up to work with. But I wondered if it's worth, not necessarily practically implementing, but at least scoping, the current landscape, which I know changes a lot depending on the models. But, so like, I think there's right the other end, you could have a $10,000, workstation with a couple of GPUs that probably needs, over 500 watts, but could still be offline, down to, something in the middle, like an Apple Silicon Mac Mini, that probably uses less than 50 watts, certainly less than 100 watts, and could probably do 40 tokens a second. Or Orange Pi, which, is very similar to that, but has a GPU. So I think not much more power than the Raspberry Pi, but I guess a bit more cost, but can maybe do like 3 or 4 tokens a second instead of half a token a second. So I guess, yeah, my question is, how do you see this landscape? And do you think you could have multiple, I mean, I say products, I don't know if that's the right term, but like multiple implementations of your same stack, which would be this nice interface that makes an educational application and feeds into your partners, but that could be implemented on different hardwares, like in a sort of modular fashion?
Yeah, that's thank you. That's truly, I'm happy you grasped like really the message here. And I don't know if Malik, you would like to address some of
Yeah,
the.
so I think the evolution of future embedded system like Raspberry Pi will make a lot of difference. So the point here was to try with what we know, but the framework we use, the software we use, are not blocked to Raspberry Pi. So we can really imagine using something else. Yeah, like there's NVIDIA chip with GPU that can be interesting because they say it's low consumption too. So yes, really, it's. I think depending of the AI task that need to be used, we can imagine different chips. Yeah.
Correct.
Yeah, I haven't seen much new questions, but there was a question that Ayesha from Tamlimabat asked. I don't know if you want to delve into your question or that was enough of an answer in the chat. I'm also seeing from. I don't know if we have. You got the answer. Okay.
Yeah.
There's another question here. I wanted to say, would be nice to see this move onto cell phone to increase hardware availability on offline that lives on device. And then a question from Guy: could we have a low and middle income country offline benchmark to encourage developers to make smaller models?
Yeah, very good points. I think that the cell phone part, as I mentioned during the presentation, yeah, of course, there's going to be a huge development there, given the capacities of these devices. But as we don't see only the model alone, we think, I mean, as we see this used in conjunction as a more broader approach in education with other tools and other resources, not just the AI model. There must be other things in the shop if you want. So definitely, yeah, there are some advances that will be done there, and it'd be nice to see how we can complement different approaches. But that there is an interesting, of course, line of development there. And yeah, what do you think about Guy's question about the offline benchmark for encouraging developers to make smaller models? Do you have a?
Yeah, the point with smaller model is the game with accuracy, and so they are doing, every model who go out now is smaller than before and better than before, but I don't know at which point it's like, if we want a chatbot with 1 million parameter, I don't think it will be possible at some points. But more and more the models are smaller with the same or better capacity.
Yeah, exactly.
So,
but I do think that one of the main things to advance is prompt engineering and actually understand the critical thinking skills. That technology will just get better, we know that, but we need to get better as well. And particularly in education, things move super slow. So yeah, I think we need to put specific attention to this topic. We see it a lot at Beekee. Again, we're against parachuting technologies. We just want them to be like adapted and really well adopted by people. So yes, I think that's one of the main points. And I've seen the AI for Education is doing a great job at providing tools for prompting for teachers and all that. So that I think we definitely need to really put as important as the tech to get the humans in the loop a bit more advanced at that level. So that we do think that there's something that needs to be on there. So yeah, that's just our 5 cents on and the tech and pedagogy that we think that need to be move ahead together.
Yeah, thank you so much. We're 2 minutes over, so I think we will drop now the conversation. Please feel free to send questions directly to the presenters who have put their emails on one of the chats, or to us directly, and we will make the connections with the team. Thank you so much, Sergio and team, for your presentation today, and we will follow up for the materials to share them as well widely with the community who has asked for them. So thank you so much, and see you for the next coffee chat in about a month's time.
Thank you, bye.
Goodbye. Thank you so much. Bye.
Thanks.